Okay, in section 4, we're going to be talking about factoring polynomials. So we've been dealing a lot with polynomial operations, addition, subtraction, multiplication, division. And now we're just going to talk about a very important topic in algebra, one that we're going to use a lot this year. It's factoring, and factoring these polynomials. So let's start with the definition of factoring polynomials. So when you factor a polynomial, that's essentially breaking up a polynomial into simpler terms, and we're going to call those terms the factors. Let me reformat here. So breaking up a polynomial into simpler terms, that's the factors, and then we're going to say that these terms, when multiplied together, should equal the original polynomial. So a lot of people think of factoring as almost the opposite of multiplication. We're going to undo multiplication. So we're going to factor these things into simpler terms so that if we multiply them back together, it gives me the same thing I started with. And there's quite a few methods that we're going to use to factor. So we've split this up into 2 sections. We're going to spend a lot of time making sure we're good and we've mastered factoring. And the first one is called factoring out a GCF. So factoring out a GCF, and if you haven't heard of this term GCF before, that just means greatest common factor. Greatest common factor. So we're going to pull out a greatest common factor. So let's look at these examples. When we factor out a GCF, 4x minus 2, we need to first record what the GCF is. So what is going to be our GCF? Well, they both have a factor of 2 in common. They don't have any variables in common if I'm looking at both of these terms here and here. So my GCF is going to be 2. That means I can factor a 2 out in front. I'm going to put that GCF out in front. So what happens when I divide a 2 from 4x? Well, I'm left with 2x. And what happens when I divide a 2 from negative 2? I'm left with negative 1. So this would be my factors by GCF. So in the definition of factoring, we know that our factors should always multiply back out to give us what we started with, the original polynomial. So if I wanted to check this, if I wanted to check my work, I could take 2 times 2x minus 1, distribute that 2 out, and I should get what I started with. Well, 2 times 2x is 4x, and 2 times 1 is negative 2. So we do get what we started with. That means these factors are right. Let's look at the one to the right of this. We need to know our GCF. We need to know our GCF. So what numbers do these have in common? Well, I can definitely divide out a 7 from 14 and a 7 from 42. That's the largest number I can divide out from both. So 7 is part of my GCF. If I look at the x's, they both have at least x to the first, so they share an x, and then they both share at least y to the second power, so y squared. So I'm just going to go one variable at a time and determine that my GCF is 7x y squared. That's what I put out front when I factor. I need to put a space now for what I take out. So if I divide out a 7xy squared from this first term, Well, 14 divided by 7, that gives me 2 left. I take an x away from x squared. That gives me one of these x's. And then I take a y squared from y squared, so that factors all the way out. I'm going to do it from the second term now. I'm going to divide out a 7xy squared. 42 divided by 7 would give me a plus 6. X and x, well, those divide out. And then I'm taking y squared from y cubed. So that means I have just a y left. And there's my factors. Let's look at our next polynomial here. We need our GCF first. So our GCF, all of these definitely share a factor of 3. As far as the x's go, they at least have x to the first power, and then they don't all have a y, so I'm just going to say it's 3x. Now, a lot of the times, with the greatest common factor, if that first term is negative, we want to go ahead and factor that negative out, because it's always nice to have our first term be positive. So if I take a negative 3x as my GCF, I'm going to factor that out. That means I divide that out from each term. So there's my first term. If I factor out a negative 3x, it's just going to be positive 1. X to the third power is what's left. If I factor out a negative 3x from this, well, 6 divided by negative 3 is negative 2. And then x cubed divided by x gives me x squared. Sorry, my pen is really working rough today. There we go. X squared. Last one, if I take it out of this last term, negative 3 from 18. If I divide that, that's going to give me negative 6. X from x, well, those cancel, and I'm left with a y. There's my factors. Last one, if I have a GCF between these two, well, they definitely have a factor of 2. They both also share an x to the first power, so 2x. So 2x is my GCF. Let's factor 2x or divide 2x out of 8x squared. I'm left with 4x. And 2x out of negative 2x, that's negative 1. A lot of people forget that, but don't put 0 here. 2x divided by 2x is actually 1. So 2x times 4x minus 1. Okay, we want to look at method 2 now, so factoring trinomials. And first thing I want to note, reminder of what a trinomial is. We talked about this in section 1. It has 3 terms. Polynomial with 3 terms. Now, we're going to see these in standard form. So standard form will look like ax squared plus bx, plus c. Where a, b, and c are all just values. They're different numbers. A, b, and c are all just different numbers here. When a is 1, means that all of these squared terms are just going to have a coefficient of 1 in front. That's it. So the first example is just x squared plus 8x plus 12. And what we're going to be doing is what's called the box method. Now you might have seen other methods. Feel free to use other methods if you learn them, but the box method seems to work for all trinomials, even when a is greater than 1. So I want to use this box method on these. I want to introduce them now, and then we'll go from there. So for this box method, obviously we're going to want to create a box, hence the name. And then we're going to split it up into 4 quadrants. In the first quadrant, we're going to put the first term. In the last quadrant, we're going to put the last term. Now in the other two quadrants, what we're going to do is we're going to take the first times the last term. So I'm going to say that's A, if we look at standard form, times C. That's 12, right? 1 times 12 is 12. And we need factors of 12. Let me jot this down. We want factors of 12, so things that multiply to 12, that add to the middle term, 8. Factors of 12 that add to 8. And again, I get 8 from right here. Well, all the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which one of those add to 8? That's going to be our 2 and 6. That's what I put in these boxes. I'm going to split this up, this 8x, into 2x and 6x. Now, it doesn't matter which one goes where. It's all going to get taken care of in our next step. So I split the 8x up into the other two boxes, 2x and 6x. And now I want to take the GCF of every row and every column. So here's our first row. If I take a GCF of this, it's just going to be x. So my first GCF is x. The next row, if I just take a GCF of this, it's going to be 6. They both share 6. The next column, I should say, x squared and 6x. Well, they have an x in common, so I'm going to pull a GCF out of x. The final column, what's the GCF? That's just 2. And we have our factors. So our factors are two binomials, the first being x plus 6, and the second being x plus 2. And there we go. Now keep in mind, if I multiply these factors out, by definition, it'll definitely give me what I started with. It'll definitely give me that x squared plus 8x plus 12. Okay, so let's go to the next example over here. Use the box method. So we're going to make our box. The first box goes for the first term, x squared. The last for negative 11. And remember, it's a times c is what we're doing next. A times c. 1 times negative 11, negative 11. We need numbers that multiply to negative 11, add to negative 10. Well, negative 11 only has one factor. Or two factors, 1 and 11. Now, which one of those is going to be negative? Well, if we make the 11 negative, if we make that 11 negative, that means it's going to add to negative 10. That's what we want. So I'm going to go ahead and put negative 11x and 1x, or just x. Factor out the rows and columns. First row, GCF of x. Second row, GCF of nothing, so just 1. We can pull out a 1, that's all they have in common. First column, GCF of x. They both have at least one x in common. Next, GCF is negative 11, so let's divide a negative 11 out. We have our factors now. If I read the x plus 1 first, and then next would be x minus 11. And those are our factors of that trinomial. So let's just do two more of these examples. The first one being the x squared plus 5x minus 6. I'll run through this one maybe a little quicker if you're getting the hang of this. So I'm going to create my box. First one goes the first term. Then the last term goes in the last box, negative 6. A times c. Well, that's negative 6. Factors. Well, factors are 1 and 6, 2 and 3. Now, one of these has to be negative. Well, we got to think. If we're adding the 5, I'm going to choose this first option, make that one negative. Because that multiplies to negative 6, and that adds to 5. So now I'm splitting this up into minus x plus 6x, and I'm going to look for the GCF of each row in each column. First row, just an x. Our second row, they both have a factor of 6. I can pull out. First column, they share an x. Second column, let's take out a -1. They both have a negative. And we talked about this before. When the first term has a negative, you always want to pull out a -1 there, at least. So we have our factors, x plus 6, and then x minus 1. And there we go. So the last one I want to do, and the last one that's on your notes of these 4, is actually this one down here. So let's look at this trinomial. We know it's 3 terms, so we're going to use the box method. First term, x squared. Last term, -30. Well, we know we need to multiply a times c, multiply these two, to give us -30. We need factors of 30. So I'm going to start listing these. We got 1 and 30, 2 and 15, 3 works, 3 and 10, and then 4 doesn't, 5 does, 5 and 6. The key is these have to add to -7, and we know one of these has to be negative. So the first isn't going to work, the second isn't. It looks like the 3 and 10, if we make that 10 negative, that's going to add up to -7. So these are the numbers we want to split it into. I'm going to write -10x and 3x. Again, it doesn't matter if I put the 3x up there or down here. Okay, factor the first row, that's an x. GCF of the second row, we can take a 3 out. GCF of the first column, another x. GCF of the second column, let's take out a -10. They both have -10 in common. So, x plus 3, x minus 10. And there we go. And lastly, we're going to do a combination of method 1 and 2, using GCF and factoring trinomials. Oftentimes, once we get some factoring skills down, we actually have to combine some methods. So you're going to always want to keep all the methods we've done in mind, because we have to combine some to factor completely. So let's just jump right into this and look for a GCF first. So we want to look for a GCF first between these two. And it looks like if I look between all 3 terms, all they have in common would be a factor of 2. So I'm going to go ahead and pull that 2 out. I have a 2 and a bunch of stuff in the parentheses. Well, 2 out of the first term is x squared. 2 out of the second term, 14x. And 2 out of the last term is 48. So I have that 2 out in front, but now I see something that I know how to factor in the parentheses. That's a trinomial box method. Box method is our strategy here. So I'm going to create the box. First term goes the x squared up in the top. Bottom right is the 48. And we need factors of a times c, so 48 times 1. That add to, that add to 14, that number, right? That add to 14. So, if I think about the factors of 48, I know 1 and 48, I know 2 and 24, .48 and 3 divided by 3 doesn't work. Or yeah, it does. 3 and 16, excuse me. 3 and 16. I know 4 and 12. I know 6 and 8, and I think I've got there. I think 6 and 8 is the one we want, because 6 plus 8 is 14. So, I'm going to factor out my first row, GCF of x. The second, they have a GCF of 8. The first column, GCF of x. The second, they have a GCF of 6. So, off to the right here, I'm going to write my factors. I still have that 2 out in front, that GCF of 2. But then, instead of that trinomial, I now have 2 binomials. I have x plus 8 and x plus 6. There's my final factors. So GCF, then factoring trinomial. Let's try this one next. So my GCF is definitely going to be, between these three values, a factor of 6. So I'm going to pull out a 6 from all of these terms. I'm left with m squared. If I pull out a 6 from the second, that's plus 2m. If I pull out a 6 from the last, that's minus 24. 144 divided by 6 is 24. Again, trinomial, box method. Create my box. I have m squared and negative 24. From there, I need factors of negative 24 that add to 2. So thinking about the factors of negative 24, we've got 1, 24, 2, 12, 3 is no good with 24. Actually, no, 3 and 8. 3 and 8, my mistake. And then finally we have 4 and 6. So we need one of these to be positive, one to be negative, because it multiplies to negative 24. Well, if I make this negative and 6 positive, adding these two would give me that 2 that I want. So we're going to say that 6m and negative 4m. I'm going to go ahead and factor the GCF out of my rows. So that's m. They share a negative 4. My columns, that's m. And then they share a 6. My final factors, I'll put that off to the right again. I have a GCF of 6. Then I have 2 binomials that I just factored into. M minus 4 and m plus 6. So what I want to do with the rest of these then, there's 2 more at the bottom, is I want you to try these on your own. I'm going to pause this video with Edpuzzle. And then once you try these, you can continue and then it'll show you the solutions. If you have any questions, please ask me while you're watching this video, and then use this for your assignment in Section 4, Part 1.